Following circuit with resistors R1 is equal to 5 ohm and R2 is equal to 3 ohm. Both these resistors has been connected in series manner. And the current source I1 is supplying 5 ampere. Determine the voltage drop across the current source using Kirchhoff's voltage law. Since the resistors are in series, the current passing through them is the same. That is, the same current I1 has passed through R1 and R2. So the direction has been mentioned here. The voltage source potential difference plus and minus has been represented, and for resistor R1, that is VR1 is the voltage drop across the resistor R1, VR2 is the voltage drop across the resistor R2. Hence, according to KVL, VS minus VR1 minus VR2 is equal to 0. And VR1 has been represented as the current I1 into R1 is nothing but VR1. Similarly, the current I1 into R2 is nothing but VR2. So now we are equating Vs is equal to I1 R1 plus I1 R2, that is 5 ohm into 5 ampere is nothing but VR1, and 5 ampere into 3 ohm is nothing but VR2, that is 15 voltage. So Vs is equal to multiple voltage plus 15 voltage. So totally Vs is equal to 40 voltage. And consider the other example. The below circuit is having two loops. There are two voltage sources. V1 is equal to 5 voltage and V2 is equal to 2 voltage. The currents I1 and I2 pass through loops 1 and 2 respectively with resistances R1 equal to 2 ohms, R2 is equal to 3 ohms and R3 is equal to 1 ohm. Using Kirchhoff's voltage law, find currents I1 and I2 that is flowing through loop 1 and 2 respectively. Given circuit has two loops, that is I1 and I2 passing through loop 1 and 2 respectively. When dealing with circuits containing two touching loops, to determine the current through the shared resistor, we subtract one loop current from the other loop current. This approach ensures that we account for the flow of current through the resistor from both directions in the circuit. For example, for loop 1, the current flowing through the R3 resistor is considered I1 is in the positive direction, then I2 in the opposite direction. So the current through the middle resistor R3 is the difference of currents, that is I1 and I2. So let current through R3 be I1 minus I2. Using KVL to find the loop equations, we are getting the voltage source 5 minus 2 times of I1 minus 1 into I1 minus I2. That is 0 equal to 5 minus 2 I1 minus I1 minus 2 minus plus I2. So we are framing the equation of 3 I1 minus I2 is equal to 5. For considering the loop 2, minus 3 I2 plus 2 plus 1 into I1 minus I2. So 0 is equal to minus 4 I2 plus 2 plus I1. So the other equation is minus 4 I2 minus I1 is equal to 2. By solving these two equations, we are getting the current I1 is equal to 2 ampere and I2 is equal to 1 ampere. Now we can able to understand the concepts of KCL and KVL. Let's apply them together to solve electrical circuits problem. These are the step-by-step procedures we can use to solve the problems. First, we have to identify nodes. Begin by identifying nodes where current converge or diverge. Label these nodes for clarity. Define branches and loops. Outline the branches, components, and loops, that is closed pathways with the seed and the circuit. Apply KCL to nodes, that is algebraic sum of current entering the node is equal to algebraic sum of current leaving the node. Then apply KVL to loops. Choose loops within the circuit and apply Kirchhoff's voltage law to write equations representing voltage rise and drops around each loop. So summation of potential rises is equal to summation of potential drop. Solve these equations to determine unknown voltages or currents. Then verify and analysis. Once you solve the equations, verify the results by checking for consistency with Ohm's law and other circuit principles. Analyze the circuit behavior based on the